Now we want to include what? We want the API should return data in XML format also. So client, if a client is expecting response in XML format, the API should return the data in XML data format. And if a client is expecting in JSON data format, then it should return JSON data format. Okay. XML, although even though XML is not a recommended data format right now, but you should have an idea about the header called as accept header. Okay. So based on the header, the accept header value, our API should respond with the JSON format or with XML format. Now let's see. For one endpoint I will show, and for the other endpoints you can just put the same thing. Look at this. This is the endpoint in our application which is going to produce the response in XML format. Not in JSON, it is in XML format. Correct? So we are, the thing is now it should produce the response in both JSON and XML. So if a client requests for JSON, should return the response in JSON. If a client is requesting for data in XML format, then it should produce the data in XML format. So I can write like this now. Producers is an array, so we can just pass multiple values to the producers. Multiple media types can be configured. So let's see how it is going to be. I can say application / JSON, comma, application / XML. This is another media type. Application / XML. Produces application / JSON, application / XML. Correct? So within curly braces, it's actually array. It is a string array. So that's why we can pass multiple values within curly braces. This is a string value 1. This is a string value 2. So we have the two string values, string value 1 and string value 2. There are two string values we are passing here, application / JSON, application / XML. Two string values. Now, to this endpoint, when a client makes a request, and if the client is asking for JSON, then it should return the response in JSON. If the client is asking for XML, then the endpoint should return the data in XML format. So how does the API know that, this REST endpoint know that the client is asking for XML or JSON? In the request, there is a header. That header name is called accept header. Accept header of request tells, okay, what data format that the client is asking for. Otherwise, the client wants to consume. Okay, accept is a header that tells the server about the response data format that the client wants to consume. There is something called accept. For example, if accept header value is application / XML, okay, if the accept header is application / XML, which means client wants to consume XML. If accept header value is application / JSON, which means the client wants to consume the response in JSON format. So based on the accept header, our API will return the response either in JSON format or in XML format. Next. Let's open pom.xml. To convert the Java object to XML, means serializing the Java object to XML. Okay. To serialize the Java object to XML. In pom.xml file, you have to add one dependency. Okay, let's say some dependency that we need to add. That dependency is related to XML because anywhere, but we need to add a dependency. Let's see what's the dependency to be added. Okay, dependency. Now the dependency contains a group ID, and the group ID is something like this. Just a minute. Yeah. So now let's move on. Here I'm just going to add something. What is that? The dependency that I'm adding is like this. This is for XML. So Jackson data format XML. This is a dependency required. Okay, this dependency is to serialize the Java object to XML format. It is a dependency. That dependency can be used to serialize the Java object to XML format. Jackson data format XML. So now sync the Maven changes. It's happened. So it is syncing now. This is the one dependency that we need to add. Now let us test. We will send a request from Postman. We'll send a request from Postman. Okay, let's see. First, let's run this application. Only for one endpoint, I have I have changed the application XML as well. I mean to say that I have added the producer's value as JSON and XML. It means this endpoint can produce the response data in a JSON format, and also it can able to generate the response data in XML format as well, and it depends on the client. Just if I include for one endpoint, you can test for the other endpoints as well. Similarly, you can also use for consumes. Let's run this application first. Okay. Now the Tomcats are done the port number 8787. Let's send the request from Postman. We'll send the request from Postman. Let's open the Postman first. Okay. Now enter the URL http:// localhost : 8787. It's a GET request. Let's say /API /employee, and let's say for example 7993. Okay, I would like to get this is a client application, and let's say the client wants to receive the data of an employee with ID 7993, correct? That's good. But if you look at the headers part, in the headers part there is something called accept header. Right now the accept header is containing value as a */*, means it will accept any media type. Okay, it will accept any media type. Accept header. Okay, the accept header is added to tell the server that Postman can understand and process all forms of response content types. Okay, you can read the tooltip message there. The tooltip message says that what the accept header */* is added to tell the server that Postman can understand and process all forms of response content types. It is recommended that this header be sent, but you can remove the header or enter a new one with a different value. Okay, let me send the request now first. This is the header that we are discussing here, okay? This is the header we are discussing. Okay. Good. Post is one more header. User agent is Postman. We are not sending the request from browser. We are sending the request from Postman. User agent means the client. Accept is a header. Accept encoding, connection. Okay. Let's click on send. Now I got the response in JSON format, but not in XML. Okay. Why? Why is a very simple, because if you look at the controller, if you look at the employee controller, in the employee controller, the producer's value is application/JSON is the first element in the array, in the producer's array. By default, it produces in JSON because the first value is application/JSON. Okay. Let's go to Postman. Now, accept header is right now the value is a */*. What does it mean? It is telling that the Postman can understand and process all forms of response content types. But now we can just uncheck this accept, and we can add the new value for accept. Accept application/XML. Okay, you can add this header application/XML, and now try to send a request. Now this accept header tells the server that this Postman, the client, can process the response content type as application/XML. Now the server will respond and the server will send the data in content type application/XML. Now you can see the response is not JSON format, it is sent like an XML format. The object class is a root tag and the fields of the object as child tags of the parent tag. And the data of each field will be sent within tags. Now this is the response in XML format. And for the same, if accept header is JSON, now you can see the same response, but it is sent in a JSON data format. The server has responded with a JSON data format. So means how does the server or our REST API can understand what response content types the client can process. So it can understand based on accept. If the client sends accept header value as application/JSON, then the REST API will return the response in JSON data format. If the client says accept value is application/XML, then our API will return the response in XML data format. So, this is how the accept header will play a role in telling the server that what response content type the client is expecting and the client can process. This is one more point that you have learned today. Like produces, consumes also same thing. Even for consumes also. Consumes tells the client like the client can sometimes send the data in XML format or the client can send the data in JSON format. But when the client is making a request, the client should tell the server, otherwise server can mismatch. Means the client has to tell the server that in the request body, the data is a JSON format. The content type of the request is, the content type in the request body is a JSON. The content type in the request body is an XML. So how does the server understand, how does my REST API can understand that the data sent in the request body is a JSON or XML? First it will look for content type header that is sent in request. Based on that, it will process, it will deserialize the data from XML format to the Java object or JSON format to the Java object by using appropriate converters. So let us test this consumes as well, so that it will be good. Now I am not using produces, I am only using consumes, because already produces I have explained here. You can add multiple content types. These are called MIME types. MIME. We can add multiple MIME types to the produces element. Similarly, we can add multiple MIME types to the consumes element as well. So consumes, I am writing application/JSON, application/XML. Which means this endpoint of the REST API consumes the content type in the request body as a JSON or even XML. It supports both. But how does this REST endpoint understand that the data sent in request is the content type of the data in the request body is a JSON, or the content type in the request body is an XML? How does it understand that? How does it know that? So there is content type header. If a content type is application / XML, this content type header tells about this to the server. Content type application / XML tells the server that this client is sending the response, the data in the request body in XML content type. And if the content type is applications or JSON, then server understands that the data sent in the request body is a JSON. The data format is JSON. Let's see. Now we want to test this endpoint called save by sending JSON and by sending XML. Let's run this. Okay, now let's test the save endpoint now, not this get endpoint. Okay, HTTP method is post. So the request is HTTP localhost 8787, okay, /what API /what save. Then we know go to the body. Because you need to send data, I mean the client has to send data in the request body. The data should contain a format. What formats that the server can consume? Either XML or JSON. So click on the body tab. Previously we know JSON. Now we can send JSON also. For example, if I'm sending the request in if I'm sending the data in the request body in a JSON format. JSON is a data format for the request body. So I can send the data in a JSON data format. So I'm constructing a JSON data. Employee number. Let's say 7331. Okay, employee number 7331. Next, employee name. Wood is the name of the employee. Next, sal. Let's say 8,000. Then department. Let's say research. Okay, now I want to add, I want to save an employee. I want to send a new employee data to the server, and I would like to save it in the database. Employee number 7331. Send. Okay. Yeah. Now we got a response 201 created and wood is created, and I got the response in JSON format. But if you look at the headers sent, in the headers you can find header type, header name is content type. Content type is what? Application/JSON. This header was automatically added by Postman. The content type header is added to help the server identify the media type of the request body that is present in this request. Okay. This header is added to help the server identify the media type of request body that is present in this request. It is automatically added by Postman. Applications.json. If I type in XML, it will add applications XML. Otherwise, if you want, you can also type manually as a key value pair. You remove this content type and you add manually by writing content type applications as XML. Okay, this is the content type. The content type header will tell the server about the media type of the request body. Okay, good. Now let's go to body tab. Now instead of JSON, you just choose XML here. And now you have to type the request. You have to enter the data in XML format. Employee, that is a model, and the fields are employee number. And let's say, for example, 7050, that is employee number. Then e-name. Okay, e-name. That can be some name. Let's say Butler. Next one is sal. Let's say $5,000. Department. Let's say IT. Now let's close employee. Okay. Now you can see when I click on send, automatically the header, content type header is calculated as automatically added by Postman as application/XML. Now the server will identify the content type in the request body is XML, and our endpoint, this endpoint will consume XML also, so it accepts. If it only has a JSON, it doesn't consume XML, then you will get data mismatch format. Exception will be thrown. Okay, right. So let's try to click on send. Then the one more employee is added. But you see headers and content type header is what? Application/XML. It is automatically added, and the content type header is added to help the server identify the media type of the request body. The media type of the request body is application/XML. This header we no need to calculate or we need to add it manually. Postman will do automatically. The header was automatically added based on the type of the data. If it is XML, it will add applications/XML. If you type JSON here, the raw data is a JSON, then automatically the header will be added as application/JSON. Okay, right. So the learning to understand in the REST controller, when you are writing produces attribute and or when you are writing consumes attribute, you can also specify multiple content types. Okay, and based on the headers, content type header, and based on accept header, the server can identify what response type the client can process, or what media type of data is sent in the request body. Based on that, with the help of converters, either Java object is serialized to that JSON or XML media type, or the data in such media type like JSON or XML will be deserialized to the Java object. Okay. So this is the learning of multiple values to producers and consumers. Next. So both I have shown. One is to respond with XML data, and other one is to accept the data in XML. Okay, into our REST application. So both I have shown you. Right. Now. Okay. Next one. What is parse mapping is the next one that we need to understand. Let me open the document. These points I'm not including in document. You just remember on the fly. But the other things I'll add in the document. Let's understand about parse mapping. Okay, now here you need to understand something. See, your Spring Boot backend application, this is your Spring Boot API, means REST API. So your Spring Boot REST API is running on HTTP localhost 8787. Okay, and this REST API has a front end application. Means there is a front end application who wants to fetch, call the API and fetch the data, who wants to call the backend application, and this is maybe your front end application, and that front end application is like a React application. For example, this is the React application, and this React application is running on the port HTTP localhost 3000. Correct? Now your React application is trying to invoke a REST endpoint. Okay, this front-end application, React application, is trying to access the back-end application API. When this front-end application is trying to make a request to back-end application, I can say that browser will block this request. Browser will block it, will block this request. Okay, because browser has a security policy. Right? What is the browser security policy? Same origin policy. Means when you are making a request from localhost :3000, then you can connect and fetch the data from same origin localhost :3000 only, but not from localhost :8787. It's a different origin. It's a cross origin, not same origin. Browser has a security policy called cross origin, same origin policy, but the request is a cross origin. That's why browser will block this request. Okay, right? So understand the point now. Why browser is going to block this request? Because browser has a security policy called same origin policy. Okay, it should make a request and get the response from same origin, but not a different origin, a cross origin. So it will block the request. So then, to allow the front-end application, like a React application or Angular application, to access the backend Spring Boot REST API, our Spring Boot REST API, our server application has to tell the browser. What to tell the browser? It's okay, you allow and send you allow the request from this particular front end, no problem. Don't block it. So our backend application or our Spring application should tell the browser. What it should tell the browser? It's okay, you allow the request from this front end, I will respond. Don't block the request. Even it's a cross origin, but okay, allow. Right? I mean, how this Spring application can tell this information to the browser? It's okay, you allow the request from this front end to my backend application. So in Spring Boot, of course, in Spring, of course, we have an annotation provided called at cross origin that should be added at REST controller class. And if you do not add this cross origin at REST controller, then your API is not accessible for the front end applications that are other client applications that are running on different port number. I mean a different origin. Okay, there is one annotation called at cross origin, and you must add this annotation at REST controller class. Okay, right? Now, at the time of adding this cross origin, you can tell the browser that from which origins I am okay. Normally, if I had only cross origin, it will allow all origins, no restriction. But you tell the browser that I am okay, that allow the request to my backend application. If the request is coming from so and so origin, you can specify which origins that you would like to accept. And that can be specified with this annotation with an element called origins. Origins equals to, you can specify whatever the origins, HTTP, localhost 3000, or you can add multiple values also. Okay, now our Spring application tells browser that okay, I am okay, you allow the request. If the request is coming from this origin, HTTP localhost 3000. Now my API is only accessible for the React application, not for others, because it's running on the port number 3000. Right, okay, you can specify multiple origins also within curly braces, value 1 comma, string 1 comma, string 2 comma, like that you can specify. Okay, right, and we have other configurations like which request types to be allowed. When the request comes with HTTP request method get or post, then only allow, and others don't allow. And for that, we have one more element called methods. So means basically I can write the cross origin annotation like this. Okay, at REST controller, At request mapping, that also we know. This is to define the common path for all the endpoints. It is to define the common path for all the endpoints / API. At cross origin, now I can say origins is equal to HTTP : //localhost : 3000. Then React application is allowed, comma. I can say methods is equal to, let's say, request method dot get, request method dot post. So you can just tell. Now this is my cross origin annotation. It is telling the browser, this annotation tells the browser, allow the request if it comes from the origin localhost : 3000, I'm okay with that. And also if the request method is get or post. This is what information provided to the browser. Okay, right. Then you can start your controller class, public class, employee REST controller or something like that, user REST controller, employee REST controller, whatever it is. Okay. Now, this is for one REST controller class. Consider you have multiple REST controller classes, not only single one, but you have multiple. When there are multiple REST controller classes, then you should add this annotation at a cross origin at each REST controller class. Another way, we can also do it globally. Instead of writing it at each REST controller class, we can also do global configuration. And for global configuration, we should define one configuration class. Configuration class means the annotation is at configuration. See, this is okay, but when there are multiple REST controller classes are defined, then you have to repeat this annotation at each REST controller. So instead of writing it everywhere, you can also do global configuration. But for global configuration, you should define a configuration class, and that configuration class should implement an interface called WebMVC configurer. So the configuration class can be created by using annotation called at configuration. Let's say, for example, public class, it doesn't matter, whatever it is. Okay, let's say, for example, web config implements WebMVC configurer. This is an interface. WebMVC configurer is an interface. It's an interface in which all default methods exist. It doesn't have any abstract methods. It's an interface, but the interface has all default methods. No abstract methods are there in the interface. WebMVC configurer. Okay, right? You know, from Java 8 version, it's allowed. We can create interface without abstract methods. You can write default methods and static methods also. From Java 9, even you can write private methods also. Okay, WebMVC configurer. Now let's, it's an interface with all default methods, so we need to override which method that we would like. So to enable global course mapping, we should override one method called add course mappings. Public void add coarse mappings. This is a method in this interface WebMVC configurer, and it has a parameter of type coarse registry. Now registry dot method name is add mapping. Like this we should start writing. So add mapping says which endpoint, who are the allowed origins, who are the allowed methods. For example, add mapping of */* means this mapping settings are for any endpoint. Or for example, if I write slash, even I can write like this also, /API /*. Means any endpoint that starts with API / employees, API / save, API / employees / ID, everyone. And who are the allowed origins for this mapping, and who are the allowed methods? We can write dot allowed origins, and you can specify HTTP localhost 3000 is a allowed origin. Next, dot allowed methods, and you can specify which methods are allowed. It is a string array. We can pass the values like this. It is variable arguments, directly get, post, put, like that. Delete. Like this we can specify. Now this is called global. Means if you add this type of, if you define a configuration class like this, then you no need to add the annotation called @coarse or @cross origin at each REST controller class. Now there is no need of adding, for example, @REST controller, @request mapping, value is /API, that is a common path for all the endpoints, right? Now @cross origin we are writing, but now this annotation is not required. This cross origin we can remove from the controller class, REST controller class. From REST controller we can remove this cross origin because we did global coarse mapping. Then you no need of writing the cross origin at each REST controller. Okay. Now whatever the configuration we did here, and this is applicable for all the REST controllers. It is applied to all. It is global. It is applied to all. Okay. So means to allow the front end application that is running in a different origin, now it can communicate with the backend REST API. Suppose if you inform the browser that I am okay, you allow the request to the backend from that origin. So this can be configured or can be informed to the browser by using cross origin annotation or with the help of global coarse mapping. This is called cross origin resource sharing. That is what in short called CORS. CORS stands for cross origin resource sharing. That is what actually called CORS. Okay, so this is our understanding. I'll add the statements, but now what I can do now, I can go to my REST controller, or I can define one configuration class like this. And in my example, I have only single REST controller class. So I can just go to the controller class, REST controller, I can write this annotation called cross origin. Otherwise, if I have multiple REST controller classes, instead of writing it everywhere, we can just do it a global configuration. Okay, but right now we are sending the request from Postman. We don't have any client application running on a different port. So that we are going to see at the time of consuming the application. Next, we are going to see that. Okay, good. Now let me do one thing to our application. The next enhancement. This is my REST controller, right? So here I'm adding the annotation. What's the annotation I'm writing? At cross origin. Only cross origin means hello all origins. That's it. If you want to restrict, then only you specify origins, methods like that. Otherwise, simply at cross origin. For now, I'm writing at cross origin. Then in the further example, when we are discussing about consuming the REST API, next we are going to discuss that point now. So during that time, I'm going to write some origins, methods, and a global mapping. Then we will see whether this cross origin is working or not working and how it is working. Okay. So the statements which are related to this will be given to you in the document. I will type all the statements here so far, whatever I've explained. These are the things I told yesterday, like how error response object, set the status code, mirror message, timestamp. I've given points like, okay, point wise, what are all the changes I made. Now this is called custom exceptions in the REST API. Then I told YAML. Okay, YAML, actually its full form is, the expansion is Y for again YAML, A for AIMS markup language, YAML AIMS markup language. Yesterday we saw that YAML is also most preferable configuration settings file for Spring Boot applications. Okay, YAML file looks in this way. Next. The next step now. So far we have discussed like how to create the REST API, how to define the REST API, how to create endpoints, to share the data to the with the clients by defining some get endpoints, and how to allow the clients to save their data at the server side by defining post endpoints. They can update with put endpoint, and how to allow the clients to delete the data from the server with a delete endpoint. Okay, these are all what we did. Now we need to discuss about how to consume this API, not only this API, even any other API. Suppose I am creating a Spring Boot application. My application is a client application now, not the API. My application is not a server, my application is a client. And my application wants to consume the API of some other server application. Like right now what we discussed is we have used Postman. Postman is a client. So that is an API testing tool. It's a predefined tool. It's a software. It's a one predefined application. So we use the Postman for testing whether our endpoints are properly working or not working. It's an API testing tool. Now our application can be either producer or consumer. Suppose I am creating a Spring Boot application or Spring MVC application, whatever it is. I am creating a Spring Boot MVC application. I am creating a Spring Boot MVC application. That's a WebMVC application. Now this application needs to access the data from Weather REST API. So what Weather REST API is a server application. Spring Boot MVC application is a client application. Okay, this API is developed in some other, maybe in Python or maybe in .NET or maybe in Java. Now this Spring Boot WebMVC application wants to make a call to this API and also wants to fetch the data from this API, weather information of a particular city or of a given zip code, postal code, pin code. Okay. So now this Spring Boot MVC application is not the server, it is a client. It is consuming the API of some other application, so it is client. And this is server. So maybe this is developed in some other technology like Python or .NET. But our Spring Boot application wants to consume it. This is client. Now we need to discuss how to define a client application or consumer application in Spring or in Spring Boot. How to consume the REST API. So far we have discussed about how to define the REST API and our application acts like a server for other applications. But sometimes we are defining an application, our application is going to be the client of a server. In microservices, let's say you are creating a service 1 and you are also creating service 2. Now service 1 wants to access the data from service 2. Means service 1 is the consumer and service 2 is the provider. Nothing but service 2 is a server and service 1 is a client. So we should know how to consume now. Means we want to define a consumer application in Spring Boot. Means client application. It will invoke the REST API of some server application. It invokes the REST API of some server application and it will receive the response from it. Okay, that's what we are discussing now. Okay, then how it can be done? There are two things. There are two things. Guys, there are two things. Okay. There is a class given. Of course, it is a legacy class. Spring has given one class called REST template. To define the consumer application, REST template is a class. It's a legacy class. And Spring also added one more class called web client. Okay. The two classes are Spring provided REST template class and web client class. And JDK has provided one class called, this is a new class added in, I think, Java 11, HTTP client. See, the first two are from Spring. We can use them. These are the Spring provided classes. Okay. REST template is a class. It is from Spring. Legacy class, web client class. It is also from Spring. It is a new one. And HTTP client class. It is provided by JDK. From JDK 11. Okay, we have the three classes. REST template, web client, HTTP client. Okay. Nowadays, we don't use REST template and HTTP client because both are synchronous client classes. I mean, if they call any API and they makes the current thread to wait until the response comes back from server. But web client is the most popular one now because web client can make asynchronous calls to the REST APIs. Means it will call the REST API but doesn't wait or doesn't make the current thread to wait until the server responds. It doesn't block the thread. This thread can continue its work. Later, at some point of time, the response will be received from server. Once the server sends response, the response becomes available and the client application can process the response and can use it. So, but it doesn't makes the current thread to wait until the response is sent by the server or the response is sent by the REST API. This is going to make asynchronous calls. Web client will make asynchronous calls. REST template and HTTP client both will make synchronous calls. Which means, suppose this is the client application. This is the client application. And now this is the server application, the REST API. Server application is REST API. Now, the client application uses REST template. It uses a REST template and here is some other work. Okay, some other code is there, some other work or some other code is there. Now the REST template is calling this API. Now let's say for example this API endpoint is taking 30 seconds. Then this REST template makes this thread, this client application thread, makes this current thread to wait for 30 seconds and after the server responds with the data, then only it allows this current thread to go to the next one. Means what? This REST template makes a call to the REST API and blocks the current thread until the response is received from server. And the current thread, the client thread, cannot continue its work until the response is received from server. This is called synchronous communication. Means this some other work gets executed after 30 seconds. This will execute after 30 seconds. Executed after 30 seconds. This is called synchronous communication. REST template and HTTP client both will perform. It should give an HTTP client also. That also It is just from JDK. This is from Spring. That's the difference. But HTTP client also will perform synchronous communication only with the server, the REST API. This is one class. That's why we call it as a legacy class. And to make asynchronous calls, then we got a web client. If it is a web client, not a REST template class, then it doesn't block this thread. It calls API, but it allows the thread to continue its work. It doesn't block it. Later, the response is received from API, but the thread can continue the work. Now this work, some other work gets executed immediately, no need to wait for 30 seconds. That is called web client. So REST template, okay, is the legacy class, web client is a new one. Like REST template class, HTTP client, one more class is given in JDK. Even this also we can use, but it is also a asynchronous. It is another synchronous client class. It is not asynchronous client class, it's a synchronous client class. But web client is asynchronous client class. But even the REST template is not that much used, just better to have idea about REST template. Mostly now we are not going to use REST template, we are going to use a web client. Okay. Now, in a REST template class, let us understand about what are the methods available in the REST template class. HTTP client we are not discussing. You can just, I have given the hint. It's from JDK 11. You can see how HTTP client class can be used to make a call. You can prepare one example on that, okay? But I'll give you two things from Spring Framework, that is REST template class and web client class. In a REST template class, various methods are provided. To send, for example, GET request, there is a method given called GET for object. Of course, parameters we need to pass, but it will send GET request and it will convert the response body into the Java object. Okay, but it will not give access to headers and status codes. Only it will convert the response body into Java object. Okay, but for example, in the client application, you want to get full access to HTTP response. Means the client application wants not only the response body, but also wants to access the headers and status. Then there is a method given called GET for entity. Same like GET for object, but this GET for entity will return response entity object, which contains not only the response body, it also contains headers and status codes. So to get full access to HTTP response, then GET for entity. Now the client application just only want response body, but it doesn't want any headers information or status code information, then GET for object. Similarly,